So this is my second video to analyze the recent NHT Math Method Exam 2 and answer all questions in the space provided. Yep. Written responses in English. Numerical answer required exact value. Yep. More than 1 mark available. Appropriate working must be shown. Yep. Diagrams not joined to scale. All right, so we're good to go. So the first question analyzes the cubic function here, x cubed minus px. Part of the graph is shown below when p equals to 3. So when p equals to 3, we should use f of x equals to x to the power 3 minus 3x. And if I want to find the values of the x-intercept, it's just like f of x equals to 0. So pretty much you get x to the power 3 minus 3x equals to 0. And you should get x equals to 0. And x equals to plus or minus root 3, okay? Notice that the question didn't ask for the full coordinate, so there's no need, I suppose, to write it like 0, 0, plus or minus root 3, comma 0. We just need the values, okay? For the x values, x-intercepts. Second part, use the derivative f dash to find the coordinates of the turning point of f when p equals to 3. So what I'm going to do is I will write down the explicit derivative, which is 3x squared minus 3 equals to 0. So you will get 2 solutions, x equals to plus or minus 1, okay? It is important to obey the instruction. Use the derivative f dash to find the coordinates. So I suppose it is better to write down the actual derivative, then you write down the full coordinates. Let's say f of minus 1 equals to 2, subbing in, and f of 1 equals to negative 2, which means you need to write minus 1, 2, and 1 minus 2. Okay, so that's the stationary points. Okay, now, part C1. Find the value of p, which means this time we have to use the general formula, f of x equals to x to the power 3 minus p times x, for which f would have exactly 1 stationary point. So if I say I analyze the derivative in this case, 3x squared minus p equals to 0. For this equation to have exactly 1 solution, that means exactly 1 stationary point. I would say x squared equals to p over 3, I suppose. And now, if this equation were to have only 1 solution, p equals to 0 for 1 solution or 1 stationary point, okay? Something like that. All right, find the values of p, for which f would not have any stationary point. So if there is no solution, x squared must be less than 0, which means your p over 3 must also be less than 0. So therefore, I would say p is any negative real number, or you could say p is an element of negative infinity to 0, but not including 0, okay? For no solution. All right, next, the graph of f passes through the origin for all values of p. This phrase is important. Use calculus to show that the tangent line to f at the origin has the equation y equals to minus px. So firstly, you probably need to show your substitution, let's say 3x squared minus px. Because my tangential point is at the origin, I would say, okay, f dash of 0 equals to, oh, by the way, I wrote an extra x here, should be just minus p. So 0 minus p, which is minus p, okay? And equation of tangent at the origin, 0, 0, you could write y minus 0 equals to the gradient, negative p, times x minus 0 in a bracket. Therefore, y equals to negative p times x. So that question is done. Next, find, in terms of p, the area of the region bounded by the graph of f, the line y equals to px and the line x equals to p, where p is greater than 0. So whenever we have a p greater than 0, I suppose the graph must have, let's say, 3 intercept. one intercept is at minus root p. The other intercept is 0, and also we've got a positive root p. We've just determined the equation of tangent at x equals to 0, okay? And the area bounded by the function f, the line y equals to px and the line x equals to p. Well, we could have, let's say if x equals to p is here or x equals to p is here. It's just integrating, the upper function minus lower function, okay? Upper minus lower. So this time, I suppose you could use your CAS calculator to evaluate area equals to from 0 to just p. And the upper function is your f of x. Notice that when you subtracting the tangent line, it's minus px here with dx. So you're subtracting a negative px. And using the CAS, you'll be able to get a p to the power 4 divided by 4. Okay? So that is the answer in terms of p. The expression for the area found in part D1 also gives the area bounded by a cubic function y equals to kx cubed, the x-axis and the line x equals to p, where p is greater than 0. Find all possible values of k. So let's say we could have y equals to kx to the power 3 like this in a turning point form with a stationary point of inflection at 0, 0. And this is when k is positive. You have an increasing cubic function, and you're integrating from 0 to x equals to p, okay? That means you could say 0 to p kx to the power 3 dx equals to p to the power 4 divided by 4, okay? So it's not very hard to see when you integrate the left-hand side, you get a k over 4 times x to the power 4 from 0 to p equals to p to the power 4 divided by 4. And therefore, k p 4 divided by 4 equals to p to the power 4 divided by 4. This case, k equals to 1, okay? But remember, the question gave you some hint, all possible values of k. That means you probably need to think of the other direction. In terms of the other direction, that is when your k value is less than 0. Y equals to kx to the power 3, and a k is less than 0. So it's a negative decreasing cubic function. So in this case, the region is below the x-axis. This is p, this is 0. You could say, or negative 0 to p kx to the power 3 dx equals to p to the power 4 over 4. That case will give you k equals to -1. Okay? So I would say the first question is like an entry-level question. But you do have to be very careful with part D, because part D gives you some sort of general case in terms of parameter p instead of a specific value. Okay, let's move on. Question 2, 13 marks. A simple pendulum consists of a mass at the end of a string of fixed length 0.5 meters. The other end of the string is attached to a fixed point O. So while you are, swinging the pendulum, it will encompass or go along a circular part of a circle, part of a circumference, an arc. The mass swings back and forth in a circular arc between A and C, yep, each time passing through a point B. The height, h, is here. In terms of the angle theta, is given by this function. Theta is in radian, measured anti-clockwise from the vertical line OB. So if I start with a negative pi over 3 and at pi over 3, that is like a 60 degrees back, 60 degrees forth, okay? The mass reaches its maximum height at point A, where theta equals to pi over 3. And at point C, when theta equals to minus pi over 3. It reaches a minimum height at a point B when theta equals to 0. So part A wants me to find the maximum and the minimum height of the mass. Well, in terms of the circular function, you get so used to, C plus A, C minus A. But in this case, you have to be very careful because this domain restriction is not like a full cycle or full period, okay? So the lowest point must be in the middle where theta equals to 0. H0 equals to 3 over 2 minus half cosine of 0. And that is 1. So 3 over 2 minus half is 1 in meters, I suppose. So this is my minimum height. And h of negative pi over 3 equals to h of pi over 3 due to the symmetry of this cosine function. And you get a 3 over 2 minus half times cosine pi over 3. And that gives you 3 over 2 minus half times half. So I should get a 5 over 4 or 1.25 meters. So that is my maximum height, okay? Now, find correct to 2 decimal places the value of theta for which the mass has a height h less than 1.1 meters. It looks apparent to us we need to set out an inequality h of theta less than or equal to 1.1, where theta has an overall domain from minus pi over 3 to pi over 3. So we are trying to solve this trigonometric inequality, okay? Now, it is interesting to look at eventually how we deal with the less than. Actually, I should have less than sign here, but let's see what we would get. So I need to go to my CAS calculator and see how it goes. All right. So I think I need to insert a new problem, new calculator page. Let's just say h of theta is assigned to 3 on 2 minus 1 over 2 cosine of theta. Okay, and if I solve h of theta less than 1.1, comma, for theta, given minus pi over 3 less than or equal to theta, less than or equal to pi over 3. See how we go. Okay, it doesn't really give us, a meaningful form. So I probably need to go for the, let's go for the graph, h of x. And this is pi over 3. This is minus pi over 3. And let's try using a 2 here and a minus 1 here. Okay, so if I plot 1.1 here, good. Now we can find the intersection. All right, here and here. Well, according to the original inequality is h of theta. In this case, my h of x must be less than 1.1. So I couldn't, take the equal sign at the actual value, the actual decimal values. I probably need to, round it inwards. Let's say get it to minus 0.64. But when I actually put the point at minus 0.64, the point is actually lower than 1.1. Similarly, if I put my value at 0.64 and sub into h of x, let me show you. H of negative 0.64. It is actually less than 1.1. And also, if I put a positive 0.64, yes, it's also less than 1.1. The question wants me to round the values of theta to 2 decimal places. After I rounded the values to 2 decimal places, I actually need to retain an equal sign there, okay? Because of the evaluation I showed you here, okay? So The answer is between plus and minus 0.64. Correct your 2 decimal places. All right, next. The angle theta radians as a function of time t seconds. Interesting one. Is given by the function theta between 0 to 30. That is my t. Another independent variable is between 0 and 30. Show that the mass is initially at point A. So we probably need to find the initial angle, which is pi over 3. Theta 0 is pi over 3 cosine of 0. And that gives me pi over 3. And h of theta 0, well, to show it's at point A, we need to determine its height, I suppose. That will give me 3 on 2 minus half cosine of pi over 3. And that gives me 3 on 2 minus a quarter, which is 504 meters at point A. Okay. So I suppose that's the intention of the question. And determine the period of the pendulum. The period is the time in seconds taken for the mass to travel from A to C and back to A. Well, if you look at the form of the function, the period is simply 2 pi over n. In this case, my n value is 9 over 2, okay? So that will actually give me a nice exact value, which is 4 pi over 9 in seconds, okay? All right. So that is part D. Okay. How many times for t belongs to 0 to 30 is the mass at point A? Well, at the point A, we need to make sure the h value equals to 5 over 4. When theta equals to, pi over 3, etc., etc. So I suppose you could deal with the composite function. I mean, the function, it can be written as y equals to h of theta t, okay? Something along this line. So what I'm going to do is I'll change. Actually, I wouldn't change anything. I just define an extra stuff. Define theta of t is assigned to, let's say, pi over 3 cosine, well, that's 9t over 2, okay? And h of theta t is going to be this function, okay? And then now I'm going to plot this function as a new graph. Change this to x. Okay, quite small to observe what happens. So I probably will change this to 0 and change this to 30, okay? And let's say we could have 2 here and minus 0.5 here, for example. How many times at a point A? Don't forget to include the endpoints, I suppose. You can see there are so many solutions, right? Basically, you could say, okay, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. Okay, so that is a possible way to, using some brute force method to count, okay, how many times the height is at the maximum value. But look, the angle actually swings back and forth, okay, back and forth. So you have to deal with that situation. Actually, another more efficient method is to look at the graph of theta versus t, in this case, theta versus x. So with this graph in front of us, we just need to count how many times this theta function is at its maximum, which is pi over 3, because to reach the point A, my angle theta, the vertical value, has to reach pi over 3. So you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So the answer, I suppose, is 22 times, okay? Well, do need to treat this one with care. Don't lose your count. So that's a 22. Okay. Or just y equals to theta t, count how many maximums? Maxima. Determine the distance in meters that the mass travels as it swings from point A to point C. So better refer to the diagram. From A to C, you can see the angle change. It's like 2 pi over 3, okay? The reason why also for the previous part, I ditched the method of counting the turning points on the composite function versus t is because when you look at the actual motion, reach C, the maximum height. C also gives you a maximum height, but I need to go from A to C and then back to A again, okay? That's why if I counted the number of turning points, let's say 43 or 44, I actually need to divide it by 2, okay? This is 44 is like one half turn and the other half turn, okay? So I need to divide by 2. And this is actually an arc, okay? So I just need to use the arc length formula. Say arc length formula is L equals to the radius times the angle you swing by, okay? The angle it sweeps when it moves along the arc. So the distance equals to radius times delta theta. The radius is half times 2 pi over 3. And that gives me pi over 3 in meters. The distance is in meters, okay? So it's quite an unusual circular function questions compared to the old questions in the past exams we dealt with before. Okay, right. Find, correct 2 decimal places, the height of the mass in meters after 1 second has elapsed. So I suppose you could determine the theta at t equals to 1, which is pi over 3 times, let's say, cosine 9 over 2. And then h of theta 1 equals to 3 onto minus 1/2 cosine of this value here, which is also your theta 1, okay? So the hard part is you recognize there are 2 layers for evaluations. That's why it probably assigned a 2 marks here for that reason. And let's just try our CAS calculator. So probably just get h of theta 1. Press Control Enter. The answer is 1.01, okay? 1.01 in meters. Next part of the question wants you to state the rule for the composite function h theta t. So just use h theta t, and this is the rule. Don't forget to state your left-hand side, all right? So just copy that down, and then we will come back to the last part. Okay. Now, the last part says find correct to 2 decimal places the average height of the mass in meters. The question is, should I just use, let's say, 1 over pi over 3 minus pi over 3, integrating from minus pi over 3 to pi over 3 for h theta, d theta? Or should I actually deal with the time t? 1 over 30, integrating 0 to 30, h theta of t dt. This is a very good question because if you recall from the definition of composite function, if the composite function exists, this composite function y equals to h theta of t. What is the domain? What is the eventual domain? Well, you need to look at the inner domain. That gives you t belongs to 0 to 30. And if you use your CAS calculator to evaluate theta of 30, I suppose you will get something like, let me have a look. Oh, this is an interesting one. This is not equal to pi over 3, okay? So actually, I wouldn't use 1 over the difference in theta value and integrate over theta. Instead, I would just use this equation here. So the average height eventually is 1 over 30, integrating from 0 to 30, h theta of t dt, okay? And that's probably why the exam writers put in part 2 here. So you probably want to relate it to part 3. And eventually the overall domain for this composite function will be 0 to 30. You can see the endpoint is not at pi over 3, okay? Based on the evaluation. So come back to my CAS calculator. And then I will do an integral with a 1 over 30 here, 0 to 30. And h theta of t dt. Control Enter. The answer correct to 2 decimal places will be 1.13, okay? 1.13 in meters, all right? Rounded from 1.12788, etc. So that's the end of the second question. And you can move on to the third question. Okay. Question 3. A small business has 4 people working full-time. The business rents an office, and on most days, some people work from home. On any given workday, the number of people working in the office can be modeled by the discrete random variable n with the following probability distribution. So we've got a small n value ranging from 1, 2, 3, 4, and the probabilities are 0.3, 0.4, 0.2, 0.1. They add up to 0.7 plus 0.3, yep, equals to 1. Find expected value of n, En. So all you need to do is just multiply the n value and the probability values, okay? So what I'm going to do is expected value of n equals to 1 times 0.3 plus 2 times 0.4, 0.8 plus 0.6 plus 0.4. Eventually, I should be able to get a 2.1, okay? Or if you wish, you could retain your answer like 21/10 or 2 and 1/10 as a mixed fraction. Find the probability that all 4 people are working in the office, given that at least 2 people are working in the office. So let's set it out like a probability with capital N equals to 4 exactly, given N is greater than or equal to 2. Okay, something along this line. So your numerator should just be probability N equals to 4. The denominator is probability of N greater than or equal to 2. And then we can refer back to the table. Probability N equals to 4 is 0.1. And the probability of N greater than or equal to 2 is excluding 0.3. So we have 0.7. So the answer, the question didn't give us any rounding instruction. And I suppose we need to write the answer as 1/7, okay? Not the decimal approximation. Okay, in a fortnight with 10 working days, find the probability that all 4 people are working in the office on at least 3 days. So let's say probability of N equals to 4. That is 0.1. And we can treat it like a probability of success. And a totally number of trial equals to 10, okay? So let's call it working is following a binomial distribution, N equals to 10, well, and a P equals to 0.1. So I would like to have 3 of such days. So probability of W greater than or equal to 3. I'm going to use a binomial CDF. On my TIN SPY, it's binom CDF 10, 0.1 from 3 to 10, okay? So if I trust my CAS calculator, I should be able to get 0.07019 to 4 decimal places. That's 0.0702. 1, 2, 3, 4. Yep, 4 decimal places. Okay, a nice binomial distribution question. And then we can look at next one. Okay. The business owner is trying to find ways to reduce costs. Her daily electricity cost in dollars can be modeled using a continuous random variable C, which has the following probability density function. Identify the maximum daily electricity cost in dollars for the small business. So if I just look at the effective domain, C refers to the dollars, the amount of money for the cost. So let's say my C max feasible number is 10. I'm not going to look at elsewhere because elsewhere just refers to 0 probabilities or 0 frequencies. I'm not going to look at other C values. And find the mean daily electricity cost in dollars. So you could trust your CAS calculator. In fact, part 2 and part 3. Part 3 wants me to find the probability that on any given day, the electricity cost is within 2 standard deviations of the mean. Okay, so I probably need to define the function here. Let's just do f of C is assigned to 3C times C minus 10 squared divided by 2500. And the mean value can be calculated by 0 to 10 C times f of C dC. That gives me 4, okay? So the mean value is $4. Or just 4.00 or $4. And the next part wants me to find a probability on any given day, electricity cost within 2 standard deviations of the mean. So I still need to figure out the standard deviation. Let's set out the square root and then copy that in. Then to figure out the standard deviation is calculated by the integral of C minus your mean value squared times the function dc. So that gives you 2, okay? So that is the standard deviation. Now, if it's within 2 standard deviation, to find the probability, I just integrate the function itself. So I'll copy this down and delete C. So now from the mean value minus 2 times 2. to the mean value 4 plus 2 times 2, 2 lots of the standard deviation. And that gives me 608 divided by 625. The question didn't give us any rounding instructions, so I'll just copy that down, okay? Okay, here is my responses. All right, and yep. The business owner plans to reduce electricity cost by installing LED sensors. She researches an LED sensor manufacturer and finds the following information. Part E, in a random sample of 200 LED sensors, 30 sensors were found to be defective. State the sample proportion. P hat equals to X divided by N. So we've got a 30 divided by 200. You could say this is 3 over 20. Or if you wish, you could say 0.15, okay? Use this sample proportion to find a 90% confidence interval for the population proportion. Correct to 3 decimal places. So I think I just go for my CAS calculator using the statistical functionalities. To find the confidence interval for the population mean proportion, sorry, I'm getting so used to saying population mean value in specialist math. So statistics, menu 665, 1 prop z interval, success 30 for defective number. Totally we have 200. Confidence level is 0.9. Press OK. And we want decimal values, so we press Control Enter. Now the answer should be 0.108, comma, and 0.192, both rounded to 3 decimal places, okay? Remember, this value has to be rounded to 108, and this value, you have 5 here, rounded up to 192, okay? And you can see the p hat is exactly what we calculated before, 0.15 or 3 over 20. And we can have a look at the last part. Part F, a new sample of size n is taken, which is used to calculate a 95% confidence interval. Be very careful. Using the value of z equals to 1.96, determine the sample size n. If the confidence interval for the population proportion is found to be this guy. So what I'm going to do is the p hat minus 1.96. The question told us to use 1.96, so I don't need to write it like 1.95996, blah, blah, blah. But you do have to have the correct formulation for simultaneous equations, all right? That's the lower bound. Meanwhile, I will be writing the upper bound as p hat plus 1.96 times the standard error. The square root thing is referred to as a standard error, okay? So the next thing I'm going to do is to use the CAS calculator and solve for p hat and n simultaneously. So what I'm going to do is menu 371. We have 2 equations. Let's just use p comma n, referring to p hat and n. And I've got a p minus 1.96 times the square root of fraction, p times 1 minus p divided by n equals to 0.062. And press tab, p plus 1.96 square root. Repeat the process again, p times 1 minus p divided by n equals to 0.213. Now press Control Enter. The p value is found to be 0.1375, and the n value is 79.92 something. But remember, for the sample size, we need to make some reasonable interpretation. Say we couldn't have a decimal number. We have to use the closest, let's say, nearest integer. So the sample size should be treated as 80 as a whole number because 79.92 something is closest to 80, okay? So that's pretty much what we need for the whole probability question, I suppose. So that is my potential response. And anything else I need to talk through? I would recommend you use a round bracket here because in the official VCAA formula sheet, it's a round bracket, okay? All right, question 4. Team has created a tiling pattern using transformations of the cubic function. Okay, nice pattern. Cubic function, turning point form. On the graph below, the function f is shown in bold. The rest of team's tiling pattern, actually, I would be using this phrase, tessellating. Tessellating is like you putting two identical parts with the same pattern intimately close to each other, okay? Tessellating pattern is shown with dashed lines, which are all images of transformations of f. So the translation of f given by f2x is fx minus 4 minus 4. So this is a translation by 4 units to the right, and then a translation of 4 units down, okay? It describes a different image, different edge of one of the tiles. Question part A wants me to trace over using your pencil, preferably. Described by F2 in figure 1 and label this edge F2. So don't forget to label that. Well, what you can do is just in your mind, imagine such a traced over version over your original function. If it's translated by 4 units to the right, 2 units, 4 units to the right, and then 2 units down, 4 units down, okay? So this is the part you're supposed to trace over and you write it like y equals to f2 of x, okay? Just label it. And you can see the domain has been translated to 0 and 4. Given that f has a stationary point of inflection at a -2, 2 and an axial intercept at 0, 4, find the values of ABC. So let's just make a snippet of this guy here and save the image. I'm going to insert well, I'm lazy, use the technology. This is the beauty of technology. So firstly, this is a stationary point of inflection. What I'm going to write is f of x equals to a unknown. You need to write x plus 2 to the power 3 here and a plus 2, okay? By matching the components, you actually get a b value equals to -2 and a c value equals to 2, okay? Because it's treated like 0, 0 translated to -2, 2, okay? And then you can just sub in 0 and 4. So a times 2 to the power of 3 plus 2. So you should have 2 equals to 8a. And this a value is a quarter, I suppose. Don't forget to box your answers to the question. The question wants me to find the values of ABC, okay? But it's not harmful to say f of x equals to a quarter x plus 2 to the power 3 plus 2, okay? And then question 4 continues over the next page. Now, the piecewise function P is continuous, where the first component is f from -4 to 0. The other component is a translation of f, and both are edges in Timothy's tiling pattern. Complete the possible rule and the domain for the second piece of the piecewise function P. Well, I think the key is continuous and a translation. And I have to make sure the horizontal span of another piece must also be 4 units, 4 meters whatsoever. So how could I make this continuous? Well, you could actually, let's say I make a replicator version, replicate a part of this f here, right? So if I translate it here, let's say 4 units, and then 4 units upwards, okay? You can see the blue part is continuously joined with the black part, okay? So you could say this part is, let's write y equals to f of x take 4 plus 4 with the domain of 0 to 4. This is one possible version here. Also, the question didn't restrict the direction of translation. So you could also argue that, I suppose, let me use a different color. Let's put it in a nice grape color, okay? You could translate it like a 4 units backwards to the left and then 4 units down. So you can see this one joins the function at x equals to minus 4, y equals to 0. So this version, I suppose, you could write it like y equals to f of x plus 4 minus 4. For minus a less than or equal to x, less than or equal to minus 4, okay? To create a continuous pattern, okay? So there are 2 versions. By the way, you already have an equal sign here. There's no need to repeat the equal sign, so I just need to write 0 less than x less than or equal to 4, okay? Similarly, if I did f of x plus 4 minus 4, I will join the graph at x equals to minus 4. Therefore, I would say minus 8 needs an equal sign, but minus 4 doesn't need the equal sign, okay? So there are 2 possible answers in my opinion. All right, part D, find the rule and the domain for f inverse, the inverse function of f. So remember, domain of f is the range of f inverse, and the range of f is the domain of f inverse. So I'm going to use this one. Looking at the graph here, I know my y values of f is from 0 to 4. Therefore, the inverse function will also be 0 to 4. So let's write this one. Domain of f inverse is 0 to 4 inclusive, okay? The next thing is to find the inverse function of f. So use f of f inverse of x equals to x, solving for this f inverse of x, which is your y or whatever letter it is. Okay, trust my lovely calculator. Control up. Insert problem. Add a calculator. So you could define f of x equals to 1/4 x plus 2 to the power 3. And then you have a plus 2, okay? And you could solve f bracket fv, okay? fv means f inverse or fiv, okay? Equals to x comma fiv. So that is your new function, okay? Some calculator might not be able to spit out this thing, including TI. That's because when solving this sort of cubic equation in turning point form, it might not apply the correct algorithm. Another thing is, if in this particular instance you couldn't find an explicit rule like this, you could use C-solve. C-solve, let's say f of y equals to x for y. and you just ignore whatever expression involving I. You drag it down to the end and copy down the real solution of that equation, okay? So that is some heads up for a potential issue. Of course, if your calculator is updated to 6.03 something or later, or the latest version of operating system, you shouldn't get this issue, okay? You shouldn't encounter this issue. So let's move back and look at the answer. F negative 1 of x, make sure you use correct notations. 2 to the power 2/3, x minus 2, 1/3, minus 2, okay? So that is the equation, the rule for the inverse function. Okay, let m and n be real numbers, and g of x is m times f inverse nx, be a function describing the transformation of the inverse f negative 1. Find the values of m and, given that g of x describes the tile edge drawn in -4, 0, and 0, -4, shown in bold in figure 2. So I think if I define the function here, I just need to choose y minus 1 for this function. Let's call this one g of x is assigned to that, okay? And I could just insert a graph. Let's say f of x is between -4 less than or equal to x less than or equal to 0. And how about a g minus x? Yep, g minus x. G minus x, if I restrict that from -4 less than or equal to x less than or equal to 0. Yep, exactly the thing I would like to find, okay? And my n value multiplied in front of it is just, let's say, 1, and n equals to -1, okay? M equals to 1, n equals to -1. Or you can actually reflect the graph. Okay, so that is this nice tiling or tessellation question. All right. Find the area of one of the tiles. An example is shaded in figure 2. This time, I mean, this is where I would use the tessellation instead of brute force integration, okay? The reason why I'm saying that is because, can you see my shaded part here? If I rotate this bit by 180 degrees and fill it up here, okay, I can create a nice rectangle. Similarly, I can also do a tessellation for each of the other 3 sides, okay? Each of the other 3 sides. Let's say, let's do it better. It's not perfect, but I suppose you will get what I mean here, okay? You can fill it up here. So it's another nice rectangle. And also do the rest for these bits, okay? So let me use some coloring to show you what I'm thinking. This gap can be tessellated by this bit here, okay? And this bit can be tessellated here, can be slamming here to fill up the gap. This bit and this bit. So instead of using integration, well, you could use integration. You can just find a nice rectangle, okay? So area equals to 4 lots of 2 times 4, which is 32. Make sure you also indicate what you are thinking. Using tessellation. Shown. Okay. There's nothing wrong to do an integration. You can just find, let's say, this is your f of x, I suppose. Just use your f of x, integrate from -4 to 0. 4 lots of integrating -4 to 0, f of x dx. And that also gives you 32, I suppose. All right. Using the derivatives of f and g, well, this sort of phrase repeats again and again. At least this is the third time I see that in this paper too. Show that the angle at the left corner of the shaded tile at a point -4, 0 is 90 degrees. I think, well, how about this? The question says using the derivatives. So it is the safest to write down, let's say, both derivative expressions. I defined f of x before, that's fine. I also defined g of x as my inverse function, I suppose. Hang on a second. Yep, g of x is the actually, should I use g of x, or I actually need to use g minus x? Yep, I need to use g minus x. And I could solve in x equals to -4. Yep. This is what you are going to write down, for example. The reason why I'm using g minus x is because this function g, I have to use this one as my actual inverse translated or transformed inverse function, okay? So don't get bogged down. Use consistent notations. Now, I'm going to write this down and show some reasoning. Okay, so basically, writing these two things down, these two derivatives, is addressing the requirement here using the derivatives of f and g. And then I need to show some substitution to evaluate the two specific gradients. And finally, the question wants me to prove, to show some convincing working, the angle at the left corner, which is at -4 of the shaded tile, is 90 degrees. That means the tangent to these two graphs at x equals to -4 will meet at 90 degrees, okay? So that's how I would answer the questions. All right. H. The family of functions defined by y equals to gx minus 8k gives an infinite set of edges in Timothy's tiling pattern, 3 of which are shown in bold on figure 3. 3 more families of functions can be used to bound an infinite set of tiles centered on the x-axis, 3 of which are shaded on figure 3. So we'd like to complete the table to define 3 such family of functions in terms of the given functions f or g, and the parameter k belongs to z. So this is indicated in the question. K is an integer. Now, I think it is easiest to deal with f of x first. So each time I can just translate the function f of x. This is like fx minus 8, and this is like fx plus 8, okay? Eventually, that pattern goes on and on, onwards and backwards. So the second equation is y equals to f of x minus 8k. And we already specified k belongs to z, okay? And the next thing is, if we look at the yellow part here, the yellow part is a translation of f of x. So we just say f of x minus 4 minus 4, okay? And next one is just like f of x minus 4 minus 8 minus 4. So eventually I can just subtract an 8k here, okay? X minus 4 minus 8k minus 4, okay? And now to look at the last one in green, this side. This will be you know, g in terms of g. This is your g. This is your g of x minus 4 plus 4. You shift it 4 units to the right and 4 units up. And then looking at this side or this side, okay? So eventually I just say, okay, g of x minus 4 plus 8k. Or actually minus 8k to be consistent. But it doesn't really matter if you add an 8k because when k takes negative, minus 8k is positive. When k is positive, minus 8k is negative, vice versa, okay? So last thing is y equals to g of x minus 4 minus 8k plus 4, okay? 2 marks for 3 entries. Interesting. And I could notice this bit could use plus 8k, etc. All right. All right. So that is part H, an interesting test solution question, very creative. All right. Question 5, 12 marks. F of x is e to the power negative ex. Show that the rule and the domain for f inverse, the inverse function of f, is given by this thing, where x is positive real number. Right. This is a show that. So we let x equals to e to the power minus e times f negative 1x. This time I'm not using y. I'm using f negative 1 to make sure I answer the question correctly, okay? For inverse. So we say, okay, minus e f minus 1x equals to log e of x. So f negative 1x equals to minus 1 over e log ex. Make sure you show correct naming and also the correct working out, okay? And it's not enough to stop here. You probably want to explain why this domain is this guy, okay? You say for x belongs to R, range f is gonna be R plus. You could actually draw a diagram here to facilitate what you are thinking, I suppose. This is a decreasing exponential function, y equals to e to the power minus ex, okay? This is y equals to 0. Therefore, the domain of f inverse is the range of f, which is 0 to infinity, or R plus, okay? Nice one. The graph of f and f inverse are shown below. Their unique intersection point 1 over e, 1 over e is also labeled. Find the exact area of the shaded region that is bounded by the graph of f, f inverse, and the coordinate axis. One possible way to tackle this question is to split the area into 2 parts. A1. So A equals to A1 plus A2. This is 1 over e. Notice that. Plus A2, okay? So A1 is the area under the original function from 0 to 1 over e. We write f of x dx, and then we add 1 over e to 1. This is indicated here. That's your f negative 1, f inverse of x. Then we can just trust our fantastic calculator, okay? So let's just do problem. F of x is assigned to exponential minus e times x. And fv means f inverse is assigned to minus 1 over e natural log of x. Shift plus 0 to e to the power minus 1. That's 1 over e, f of x dx plus shift plus exponential minus 1 to 1, fv of x, f inverse. So this is the final answer, 2e minus 3 times e to the power negative 2 or whatsoever. The question didn't ask for any decimal rounding, okay? So make sure you need to write, make sure you write the exact form. Some other exact form could involve, let's say, this. 2 over e minus 3 over e squared. And you may do a quick check. Yep, this is a positive value. So you could also write 2 over e minus 3 over e squared, but not this decimal approximation. The reason why I do a decimal approximation here is to make sure I calculated a positive area, okay? Okay, here's what I write, and may move on and look at the other parts. Let g of x be e to the power ax. A is a non-zero real value. Make sure you notice the restriction on your parameter. We cannot take a equals to 0. That also applies to the rest of the question, in my opinion. Consider the function g1 equals to e to the power ax, where a is 1 over e. So we want to find the equation of the tangent line to the graph at x equals to e, and sketch the graph and its inverse on the axis provided below. And also part of D, we take a equals to -4 and find the rule of G2 inverse. And I find the values of x where G2 intersect with this inverse, correct to 3 decimal places. So let's do them all together. So for part C is another CAS calculator heavy question. Let's say define G1 of x equals to e to the power of 1 over e times x. And y equals to tangent line g1 of x, comma e. Y equals to x, okay? So that's y equals to x. And if you plot the graph there, g1 of x, and y equals to x, and also you can find the inverse function. Solve x equals to g1 of y for y. E times natural log of x for x greater than 0. So these are the 3 graphs. Y equals to x as the reflective axis, symmetry axis, and also the original function and the inverse function. Now, as for the intersection point here, you can see the rounded decimal value is 2.7183, blah, blah, blah. But actually, the question didn't give us any rounding instruction for graph sketching. I probably would, let's say, use E, okay? G1 of, let's say, E. That also equals to E, okay? So you have to write E at a roughly 2.7, okay? And let's come back to the graph sketching. I'll be using blue pen to draw my, actually, the other way around. Blue pen for my original function. I need to label the equation. Y equals to 0. That's a horizontal asymptote. And when x equals to 0, e to the power 0 is 1. And it's at 2.7, roughly here. Point of intersection. And what else do I need to do? Okay. Just draw a nice I need to show a better curvature around this point, okay? Something like that. And a good asymptotic behavior, okay? This is y equals to g1 of x. The next thing I'm going to draw in orange is the inverse function, which is a log function, okay? X equals to 0, a vertical asymptote. At 1, 0, something like that. Make sure they touch each other at this place. Does this look good? Well, that's the best of my drawing ability. So I just leave my answer like that, label with the equation. Probably I could just slightly adjust the original function, etc. Okay. All right. So the two graphs, and it's not a requirement here, but you may want to draw you know, y equals to x to facilitate your symmetry observations. Okay. Yep, label the equation of asymptotes, the coordinates of the point of intersection. Yep, G1. And its inverse. Yep. Okay, now a equals to -4. And if you use the previous observation, like this question here, you have a negative e here, then it becomes -1/e. What I'm going to do is g2 minus 1 of x is -1/4 log e of x. And you can verify this using your CAS calculator. The domain is still x greater than 0. And find the values of x where g2 intersect its inverse. This time you better not use any one equal to x because they are both decreasing. It doesn't work. You will miss some solution if you equate any one of these two things to x. Instead, I'm just trusting my CAS calculator and find the values in decimal form. Let's say solve button exponential minus 4x equals to -1/4 natural log of x comma x. So there are, let's say, 3 values, okay? 3 values. So you write the 3 values now. Okay, so that is the last part. Yep. Okay. The value of A determines the number of intersection points of the graph G and G inverse. Complete the following table by stating the values of A in each case. So, where should I start with? We could have 0, 1, 2, or 3 points of intersection. But now, if you solve x equals to exponential minus a times y for y, this is the general form for the inverse function. And I'm going to use a slider, exponential minus a1 times x, create a slider for a1, yep. And -1/a1. You can see a1 goes bolded together with this a1 you assigned previously. Natural x. Okay, so when a equals to 1, yep, we have 1 point of intersection. Now, if I change the setting and I make the step size relatively smaller, 0.1 something. Okay. So if a is greater than 1 until this behavior is interesting because you can see if I take a equals to 4, there are 3 points on this section. So there must be a critical level at which these two graphs will just touch each other for this chunk here, okay? So if I say this is 2.8 is close to e to the power of 1, 2.72, analyze graph intersection. Yep. So if I take my a value equals to e, then they touch each other with 1 point of intersection, okay? So a value must be, from larger than 0, but less than or equal to e, okay? So that's the first case. Let me have a closer look. Actually, let me double check with my CAST calculator again. The question actually used AX. All right. So I actually found the other way around. But all I need to do is to take the negative of each value. If I delete the negative one here, let's try the other direction. Okay. So when a is less than 0, yep, that's fine. Yep. It's like minus 1 over e, less than or equal to a, less than 0. And if I try the other direction, which was actually previous part, we had a exponential minus 1. E to the power E1 over E. Yep, they touch each other. So the complete set for 1 point of intersection is from minus E to 0. Notice that the A cannot equal to 0 because it was specified at the beginning. And also A equals to 1 over E, okay? And 2 points of intersection is between 0 and 1 over E. And how about the 3 points of intersection? 3 points of intersection, I probably just need to test the other parts. Have a look at here. If if my a value is larger than is between 0 and 1 over e, 2 points of intersection. How about larger than 1 over e? Okay, larger than 1 over e is like no intersection, okay? And finally, if I make my a value less than e, okay, if it's less than negative e, 3 points of intersection. So the question completes itself. Okay, so I've got a greater than 1 over e, or you could write it like a belongs to 1 over e to infinity. This one you could write it like a is an element of negative e inclusive, 0 excluded, union, just one element, 1 over e. And a is between 0, 1 over e, which is already completed for you. And finally, a is less than negative e. Okay, it does take longer than I expected to complete both section A and section B. Hopefully you'll find this video helpful at some stage for your revision and exam preparation. Good luck for your November math method. I'll see you in future. Bye.